Let's say you're using Glue and you create this this function, this code to run your ETL. In this case, you have like extract, transform, and load, and yeah, that's fine. That's working okay. And you need then to create other Glue jobs as it's expected. So you just copy and paste your code and everything's working fine, but then you remember you did not treat the exceptions. And you then need to go through every one, like every code for all of the four jobs and change your code. But if you were to use a Python package, you would have a base class with the same like extract, transform, and load, and you would have an ETL. And instead of creating the code for each job, you would refer the jobs to the Python package. And whenever you needed to do any maintenance, you would just change one code and not many. And that's very cool. So we're going to talk about how to improve code reusability with Python packages and AWS Glue. Before we start, why you should watch this video. I'm a data engineer. I've been a data engineer for 4 years, and I've created pipeline architectures in startups, consulting companies, product companies, and I've used this configuration in more than 70 pipelines. And if you work in a company and wants to apply this, I'll give you a 30-minute free consulting call to discuss this and go over this and try and help you. So, how to improve code reusability with Python packages. The first topic that we're going to go through is how to structure a Python package, then how to create a Python package, how to configure Glue with to use the Python package, and then how to deploy the Python package. First of all, how to structure Python package. So when structuring a Python package, you need to think about the classes, the parameters, and the functions. In this case, we have a base class that has some parameters such as environment. You can use it like production and development and QA and testing, I don't know. You have the functions for extracting, transforming, and loading, and the ETL that actually triggers all of them. And that's pretty much it. You have like some other parameters here as well, but nothing fancy. And then whenever using this base function, you would just use have the parameters that you set, and you can also like just do the transformation, for example, custom your transformation function or all of the functions. It depends on other factors. And we're going to discuss them now. So in this case, I'm gonna bring a use case here so we think a bit about how we would structure our classes. So we would say, let's say in this specific scenario that we have three ETLs, first ETL, second ETL, and third ETL, and all of them get the data and write it in BigQuery. So in this case, we would have a base class, and extract would be custom for each ETL. The transform would be custom for each ETL, but then the load would be like getting the data that we extracted and transform it and into BigQuery. So all of those ETLs would not have to have the same code for the load if we had the base ETL, the base class. But then in this case, we also realized that the first ETL, we are getting data from S3, the second ETL also from S3, and the third ETL we are using data from HubSpot, CRM tool, to BigQuery as well. So we are going to keep the third ETL as is using the base, but then we could also use the base that we first created as base for a second class that would have we would be extracting data from S3, so we don't need to have the same code in the first and the second ETL. So in this case, our class would have extract with data from S3, extracting data from S3, and then the transform would be custom because it depends on each ETL. And then load would keep being from the base, which is data from data to BigQuery. So that's how you should structure, not should, but some basic guidelines on how to structure a Python package, at least how I did it. Think about your sources, your sinks, think about your classes, your functions, and your parameters. So you have a lot of code reusability, easy to maintain, and yeah, not a lot of duplicated code. So how to create a Python package? So we structured it, we have the code, but we need to just create it, the Python package itself that you install, and you're able to refer in other code. So in this case, you have many ways to do this actually, but I've used pip install wheel, and then I've structured this package specifically like this. A folder called packages, and then you have a subfolder called package, and you have the base TL, and then you have the setup in the packages folder. And the setup.py is basically how you create the package itself. It has the find packages function that will find all of your packages and transform them in the wheel code the wheel file that you need. So you need to run this this function, this file, Python 3 setup.py bits12, and it will generate this dist. It will generate actually like all of these build, dist, and package folder. But the important one is this dist because this is how you distribute your package. And you have the name here for your package. You have the version as you have like set up here, and it's a wheel file that you are able to then install it. Like pip install this package and all of the name. So after doing the installation, you can refer your package anywhere in your environment. It's very simple, very straightforward. And then how to configure Glue to use this Python package. Two very simple steps. You have to have the package in S3. So just as I said, like the distribution file in the S3, and then you have to add the parameter to Glue job. So in this case, we need to I have created this enable data bucket and the packages folder. And in this packages folder, we have the distribution file, which is a wheel file. Again, the same file. And you just add as additional Python modules, and you add the path to it in S3. Here's a bit wrong, but it's the path to the package in S3. And last but not least, how to deploy a Python package. So after structuring your Python package and creating it, you realize that you need to do some and configuring your glue job to use it. You realize you need to add something or create another class or whatever, maintain it, which is the goal here, have it maintained. And it's very boring to like keep doing these steps manually, creating the Python package, running all of those functions, and then uploading it manually to Glue, especially if you have a team with multiple people. So that's why it's very interesting to use CI/CD in this case. And it's a very simple CI/CD because it's basically just getting the file from your GitHub, getting the package if it changed something, and running that very simple very simple command, and then uploading it to S3. It's very, very straightforward, but it can be a bit tricky to create it because if you don't have experience with it, that's why I created here to make your life easier. So um, then like to wrap your like to finish the introduction. So whenever you add something, create something, edit something, and you upload the version to your main or your production branch in GitHub, it will always be updated in your S3 bucket, and by doing that, your glue jobs will also like have the newest version of the package itself, and yeah, it won't be a mess. So how to deploy a Python package? You need a user with access to S3 because we're going to upload something to S3, and you need to generate an access key. You need to create a Git Actions pipeline because I'm using Git. You can use like other things, but I like Git Actions. And you need to configure Git to actually be able to run this workflow. So first of all, user with access, just a simple user, and I've added, you just need to add permissions and add this policy, which is AWS managed. So it's S3 full access. It's better to have a specific, like access to a specific folder, a specific S3 bucket, something very narrow. But for this example, I've used the full access, but also important to highlight, it's very important to always have granular permissions, have the least permissions, and only the necessary permissions. And yeah, as I said, Git actions and then the S3 full access policy. And then we just need to create this link to create the access key and save that access key because we're going to use it later. And then Git actions pipeline. This Git actions pipeline will follow some steps. First of all, we need to see if we had any changes in the packages folder. Else we will run this Git actions every time, and it's not necessary and will cost us more. So only when we have changes in the packages folder. We'll set up the credentials for AWS to actually be able to access and upload something to AWS. We'll generate the package, and then we'll upload the package to S3. So first of all, get if there was any changes in the packages folder. So Git Actions has something very simple here that it's the solution for that. Only when we push to a specific branch in the path scripts packages, in this case, if anything is changed in that folder, this pipeline will be triggered. And then set up AWS credentials. In this case, we have these commands only to configure the AWS access key, secret key, and then the default region. And as you can see here, we are referring secrets.aws access key ID and for the secret as well. This is a configuration we'll talk in the next step. But the important thing here is to understand that we're using it as we would use it locally with our CLI. We're just setting up the credentials so we are actually able to connect to AWS. And then we're going to generate the package, just like in the how to create a Python package step, which is basically just enter the folder and run the setup.py. And last but not least, we're going to upload the package to S3 also using AWS CLI. So in this case, we're going to use AWS S3 for like the S3 service, CP for copy, and then we're going to copy this file that was generated when we ran Python setup, and we're going to add it to this S3 enable data packages and then the package. And here we have also like the version. You can also change the version number if you want to keep multiple versions. It's a good practice for sure, especially if you have a bit more changes and it will impact some things that you cannot reach right now. So that's our CI/CD for deploying your Python packages, your Python package, sorry. And that's it. Very simple, very straightforward, and easy way to maintain your package. And then configure Git. As I said, we are going to reach this one. We need to go to settings and then actions. And then we're going to create a secret because, as I said, in the Git actions pipeline, we need to create the secret. So we are not like displaying it in our Git actions pipeline. And here we have an engine that is secure to use secrets and credentials. So we'll create for AWS Access Key ID, Secret Key ID, and a GH token because we need it as well. And for the GH token, side note, we only need access to the repository and the workflow. So that's basically it. Summarizing, code reusability makes maintenance a lot easier. It's important to think about the class structure, the parent, the child, and the base parameters and functions. There is no right way to create a package as long as it makes sense. And like the goal is to have low maintenance, like complexity. You always have maintenance, so you need to lower your complexity. And also to lower your duplication of code, have the least duplication possible. And also it's simple to use a Python package in Glue, and it's even simpler to deploy it in S3. So it's used in Glue in a format that is updated always. So that's it. If you like the content and you want to discuss this to apply it in the company that you work on, we are offering, Enable Data is offering a 3-minute free consulting call. You can reach out to us in these links in the description. And yeah, I hope to talk to you soon, and thank you for your time.